Okay, so what we are going to be talking about today is Newton's first law of motion, which when we're talking about the first law of motion, we do need to discuss what inertia is, friction, mass, weight, and volume. So let's go ahead and begin. So remember that if you see a page and all of the writing is out, just go ahead and pause the video, take the T-notes, and then start the video up again. So Newton's first law is also known as the law of inertia. It simply states that objects in motion are going to stay in motion, objects at rest are going to stay at rest, unless something is acted on it by an outside force. Inertia is an object's tendency to resist change. And what this means is that whatever something is doing, it will want to continue doing it until a stronger force changes its state. So for example, you see this rock here, and it's pretty massive. In comparison to the human that's trying to push it, this rock is pretty heavy. It's dense, it's going to stay there, it wants to stay there, and the only time it will move is if there is a force that's large enough in order to change its state. Another example is the dishes on a table. So you want to go ahead and draw this picture just so then that way you have something to remind yourself as an example. So the dishes on the table are going to want to stay there. There's a reason why when you don't touch it, when nothing's happening, your dishes stay on the table. Now let's say that this person decided to take off the tablecloth, and if he does it in the right way, whoosh, and then the dishes are still on the table. This actually can happen. Not that you should try this at home or do it with plastic objects. Okay. So objects at rest, such as this car, are going to stay at rest. And when you're in the car, you are also going to be staying still. So there is no motion in the car, you are in the car, everything stays still. Now, if you've ever noticed an object that starts to move, what happens is you're stopped and then the acceleration of the car will move forward, but your body is still in the same place that you started. So as the car moves forward, your body is still thinking it's behind, it's back, it's still in the same place while the car is moving forward. So that's why you feel like you're being pushed back. Now, objects that are already in motion, let's say you're driving or you're in the passenger seat and you're riding along. You are going at the speed of the car. Now, let's say that the car decides to stop. As it stops, your body is still accelerating or is still moving forward. And because of this, when the car brakes, the car stops, your body is still moving forward. Therefore, you feel a push forward, or you feel this the seatbelt pulling you back. Here is an example, real life here. So the guy was riding his motorcycle or dirt bike, and he runs straight into all these tires. And so the momentum, he is moving forward, his bike stopped moving, so therefore he did not have a wall here to stop him, so he continued moving through, and his bike stopped back there. So this is stuff that you normally see when they get into an accident. Now, if there was a wall here, he would hit that, and that would stop him. But because the tires are down here, he continues forward when his bike stops by the force. So if the tires were not there, his bike would continue going. Now, friction is one of the forces that can help to slow down the state or the speed of an object, okay? So it can change the state of motion for an object. It is a force that acts between two materials. So, for example, if you were to roll your bowling ball on the floor, there is friction between the ball and the floor, the surface. And surfaces have irregularities. And the more irregularities that you have in a surface, the more friction that you have. Even smooth, polished surfaces still have irregularities. So even when you are bowling, the surface does have some amount of friction, but definitely less than like if you were to roll your bowling ball over a carpet. Now, mass. how much material is in an object is the definition of mass. It is a measure of inertia. And remember, inertia is the reluctance, the resistance to change. So the more mass that you have, the more inertia you are going to have, which means that the more force is going to be needed in order to change that object's state of motion. So if you were to kick an empty can, you would need a little bit of force, right? It's pretty easy to kick an empty can. If you were to kick a can with sand in it, you would need to put a little bit more force in it to make the can move. If you were to kick a can with nails in it, and nails are metal, okay, it's going to be heavier. There's going to be more stuff in that can. You are going to need even more force in order to kick that can. Okay, so one thing that is easy to confuse is that mass is not volume. Mass is not weight. Okay, so for example, the lead ball and a ping pong ball, they have the same volume, which means that they look like they're the same size, but they have different masses. They have different amounts of stuff. Okay, so what is volume? We mentioned volume is the amount of space that an object occupies. So when you take a look at this example right here, we have the same amount of stuff, the same mass. We have 1 kilogram of flour, we have 1 kilogram of rice, and we have 1 kilogram of coins. The difference, so the mass can be the same, but it takes up a different amount of space. 1 kilogram of flour takes up more space than a kilogram of rice. So this is more dense. And then even more dense than that is 1 kilogram of coins, which is metal. So taking a look at it from the particle perspective, we have the same amount of particles in both of these containers here. And this is 1 liter with the same amount of mass of air, 1.293 grams of air, same number of molecules. And over here, it's half the size, so it's half a liter with the same amount of molecules. So what you're noticing is that you may have the same amount of mass, but the space that it takes up can be smaller or larger. So mass is not volume. Mass is also not weight. What is weight? Weight is the measure of gravitational force on the object's mass. So it depends on your location, right? So the location may be, for example, if you were on Earth versus if you were on the moon. The gravitational pull on Earth is stronger than that on the moon. So here's the formula. It is weight equals mass times gravity, also denoted as W equals mg. So the gravity on Earth is 9.807 meters per second squared. So if I were giving you an example of a book on Earth has a mass of 10 kilograms, what is its weight? What would be the weight if the book was on the moon? Your answer would be, after you work this out, you would do the mass is 10 kilograms, and that's your mass here from the equation, times 10 meters per second squared, which is the gravity on Earth. Okay, and I just rounded that up to 10 meters per second squared. And then you get a total of 100 kilograms meters per second squared, which is a Newton. Okay, if that same book was on the moon, the gravity there is 1.63 meters per second squared. When you multiply those two items together, you get 16.3 newtons. Now remember that a Newton is a measurement of force. And after all of the calculations were done, all you need to know is that 1 kilogram equals 10 newtons. Or the units of measurement for a Newton is kilograms meters per second squared. Or the way that it's written correctly is kilogram meters per seconds to the negative 2. Now, one thing you need to wrap your mind around is that objects move with Earth. We are living on Earth. Everything that is on Earth travels in the same direction and speed as Earth. Makes sense, right? We know that Earth is revolving around the sun in a counterclockwise direction. We also know that we're rotating. So we are traveling at a speed of 107,000 kilometers per hour around the sun, which is equivalent to 30 kilometers per second. So if that were the case, if you were to jump you would think that the wall would hit you, right? Because we're going to the counterclockwise, right? So we're going to the right. And so if you did jump, you would think that that's what would happen. But because both the wall and you are going at the same speed as the earth, when you jump, everyone is all, I mean, you don't hit the wall. The wall doesn't hit you. Everything is moving at the same speed as the earth. And we say this is relative to the sun. So if you were on the sun looking at the earth, this is what you would be seeing when you jump. One other thing to note, that even though you are moving with the earth, and all objects are also moving with the vehicle. So if you were to toss a coin while on a train, you should be able to catch the coin as if you were not in the vehicle and you were not moving. So it's almost like, so if you were standing outside on Earth, you're moving with Earth, you flip the coin, you catch it, done. If you were on inside a vehicle doing this, like on a train, it would be as if the same thing, like you're on Earth moving, right? So now you're just moving on a train while on Earth. Okay, so all right, that's the end of our T notes. And what I would like for you to do is you're going to be creating a short sentence poem summary. Check your summarization station page in your notebook and you can get the details that I'm showing down here. So what you are going to do is you're going to show me your level of understanding of those notes that you just took by creating a short poem summary. Okay, so you know poem, right? You need to create a summary that is 10 lines minimum. So you can give me 10 lines or more. Each line can be up to 3 words maximum. So you cannot give me 4 words. You can give me 1 word, you can give me 2 words, you can give me 3 words, but you cannot give me more than 3 words per line. Each line is a full sentence, and I don't have any words that I'm giving you that you have to use. However, there will be specific words that you will probably use in order to describe and summarize your T notes. Here is an example poem summary of the Big Bang. You can go ahead and pause this, read this. But what you're going to notice is that it's more than 10 lines. Each line has 3 words maximum. And poetic, when you're talking about a poem, it doesn't have to be full, complete, grammatically correct sentences. You just choose 3 words and you put them together and they create a thought. Okay, so this is on the Big Bang Theory. Go ahead and read this and then get some ideas of how you would summarize the T notes that we just did. So next time I see you, I should see the T notes and your short summary.